All right, ladies and gentlemen, here we go. Section 1 of Chapter 5. Welcome to what we call quadratic functions. Oh yeah, baby. There's a lot of stuff we're going to do with this particular unit. And first things first, though, let's start with the basic vocabulary. So we're going to use this foldable. We're actually going to live in this foldable for about the next 4, 5, 6 days and continue on with this knowledge of graphing quadratic functions and what the actual basic vocabulary is throughout the next several weeks. So let's dive into this quadratic functions foldable, and we'll go first of all to the basic vocabulary flap. So if you flip open the basic vocabulary flap, you're already going to see on there a coordinate plane. And I'm going to have an example here. You scroll down. So you can jot this example down if you want to. You're going to have to pause this. But I already have the actual basics of what is the vocabulary that you're going to need to know, if you will, for quadratics. So here's the first one. A quadratic function, by definition, is a function or equation where it has any type of a degree 2. That means the highest exponent that it has is a 2. So something that's squared. If you get into something that's cubed to the 4th power, to the 5th power, to the 6th power, that's not a quadratic. They're called something different, and we'll get to that later. But degree of 2, so here's some examples down here. I'll box them for you. So you can see, yes, there's all kinds of terms in this equation right here, but x squared, that's a quadratic equation, quadratic function. This right here is a quadratic equation because there's an actual squared on it. So there's your basic definition there. Now when we graph these things, as you just saw in the inquiry lesson we did in class, any of these that we graph, they all look like this U shape. And that U shape, as we talked about in class, is a special name. That's called a parabola. Now sometimes the U shape actually can go down. It can go like this. Sometimes it can be very, let me erase that. Sometimes it can be very, very narrow like this. Like that. Sometimes it can go, really, really wide like like that. Regardless, it is always going to be a U shape, whether it's be, a really, really stretched U shape or a wider, whatever U shape, or a thinner U shape, or it goes up, it goes down. Either way, it's going to be a parabola, no doubt. Over here, there's something called the axis of symmetry, which actually goes along with the vertex. I'll talk about the vertex first. The vertex in this example up here is the actual lowest point of this graph. So when you're graphing it from left to right, it kind of bounces off this point and comes back up. That is the lowest y coordinate that you see or that will ever happen in this particular this graph. So it's the lowest y coordinate. I should put that and put chord. And this, by the way, is just the basic graph of y equals x squared. That is all it is. Okay? So this down here is your vertex. It's the lowest point, or it could be the highest point, the maximum, if we had a graph that went something like this. Like if it went up like this and back down, well then great. This point right here would be my maximum, aka it's called the vertex. Regardless, though, with that vertex, there is this thing called the axis of symmetry. That axis of symmetry is the vertical line that passes right through the vertex. So it's not there, but I'm going to dot this just so you can kind of see the idea. It's actually like we had with the incision point that we had with piecewise functions. Either way, that line right there, that vertical line that goes down right through the vertex, on either side of that, you're going to see a mirror image. So where this dot is, you go the same amount on that side, that's where that dot is. You go 2 over on the right side here, you go 2 to the left hand side of there. So if you go from here over, they're all mirror images of each other across the axis of symmetry. So there's some basics of what that is. By the way, this thing down here to the right, if you're wondering, it's just the XY table that came about from me plugging in x's to this particular y equals x squared equation. Just how the order pairs came about and where you're seeing these dots over here come from. So there's your basic vocabulary. So let's dive into, real quick, 2 examples. One example of how we actually graph an equation, a quadratic equation, when it's in what we call vertex form. And then we'll go over here and graph one where we have it in intercepts form. I'll give you a couple ideas, but you're going to need to for sure study this. Listen to this video twice, at least this part for sure, of how to get the vertex, because I'll have a couple steps for you, no doubt. But in terms of, understand it big time, because when we come into class, you're going to be using your notes here to be able to apply these notes to graphing these things and mastering how to graph vertex form and intercepts form. But they're all going to look the same. They're all going to look like U's. They're either going to be up, they're either going to be going down. So you at least know that is going to be the shape of these things. So let's do it. Alright, so let's go back to your foldable here so we know what we're doing. And here we go. So back here, you're going to go to the vertex form flap. Let's flip that open. And in the vertex form flap, anything, sure goes without saying, but anything that I'm writing here on this video needs to go in the flap. Now, when you fold up the flap on the very top part, this is what I would write right here, the example. And any steps that I give you and any calculations that we do and the XY table that we do, all of that should really go on the top. And then underneath it, you see figure 1. This is where we'll actually graph it. Okay? So here's the first thing. With vertex form, guys, right up, straight up, out of the gates, here's what I would do. Because you know this for a fact. You know, since it's in vertex form, the very first thing, step number 1, you can instantly and immediately determine the vertex. And as soon as you determine the vertex, plot it. And remember how the vertex works. It's the opposite of this H, always the opposite of this, OPP. And then it's the same as this one. So that determines the vertex. So that means here I go -4, and then I go -5. So it's the same as this guy out here. It's the opposite of that guy. Same here, opposite there. So -4, -5. That means it's right down there. Beautiful. So that's step number 1. Step number 2, instantly along with step number 1, you could tell exactly this. You could tell whether it's going to be a smiley face, like I like to say, or a frowny face. That means you can instantly tell whether the actual parabola is going up or the parabola is going to be going down. How do you determine that, Mater? Remember, it's always this. It's always the A value right here. This A value helps you determine whether it's actually going up. So if it's a positive A value, positive people smile all the time. So positive people, positive up, positive A, positive up. Yep. And then negative people frown. So negative A value means it goes down. Negative down, negative down. Frowny down, frowny down. Either way, you remember how you want to, but that's step number 2. Step number 3 is to do this. You're going to now determine what the axis of symmetry is. Remember, the axis of symmetry is the actual mirror image that goes right down through the vertex. So that means it goes right down through here. You know what I actually would also do? Since we determined that this is a +2, I forgot to do this. That's a +2. We know it's going to be going up. So right over here, what I would do is I'd actually draw a little smiley face. Right there. I would draw a smiley face. Because you know that this parabola is going to be going up. So it's going to keep going that way up there. It's going to come down here and go that way. But by the way, that means this point right there is the minimum value of this graph. That means this graph, this parabola, is never going to go below that point, ever. So that's your minimum, aka in this example, it's where the vertex is. Okay, happens to be the minimum point. Either way. So now that we got the axis of symmetry, here's what's cool. We're going to use the axis of symmetry, we're going to use the vertex, all this together to generate and populate our X and Y table. So I'm going to put 5 spots here because we always need to graph 5 points on 1, 2, 3, 4, I need one more. 5. So we need 5 points. And what I would do is this. Once you make your little table here, trying to make this as neat as I can, something like that. What I would do is I would always kind of focus on this middle one right here, because this middle one, guys, is going to represent the ordered pair that is your vertex. Always. By the way, this x coordinate is going to be where the axis of symmetry intersects the x-axis. So you know your vertex is -4, 5. That's the x coordinate. That's the y coordinate. This is my axis of symmetry. It goes right through -4. So I'm going to start populating this table of values so I know what my graph's going to look like, where -4 is my x and -5 is my y. There's no calculation with it, but that's the first one, and I put it in the middle, and here is why. Because step number 4, you're going to use now this x value of the axis of symmetry, or the x value of the vertex, and you're going to go 2 up, and you're going to go 2 down. You're populating the x column here by going 2 up, which means I'm going to get -3, -2. What do you mean 2 up? I'm going 2 up from this. So I go up 1, up another one. And then I'm going to go down, -5, -6. So I'm going up 2, down 2, up 2, down 2. But you got to have that middle starting point, that actual vertex right there, where we are. So what then do? We have to populate the rest of this xy table by figuring out what y is, what y is, what y is, what y is. I wonder how we do that. Oh, I know. If we know here that x is a -2, that means one of my ordered pairs is going to be -2, comma something. I just got to figure out that something. I got to figure out the y value. How do we do that? Oh yeah, we've done this millions and millions of times. We will substitute this x value of -2 into my equation right here, and I'm going to evaluate. And that's going to output to me what the y value is, which then in turn is going to give me this nice little ordered pair. So I'm going to speed this up so you don't have to listen to me doing this, but I'm going to actually calculate it. You do it too, and then you can verify whether you're right. So I'm going to take the -2, plug it in, and rock and roll. So here we go. Yeah, there we go. We got y equals 3. So therefore, since y equals 3, I can put that bad boy in, what, we're here, -2. So -2, 3, -2, 3. So I can put that over here at -2, 3 will appear. -2, 3 is a second point that I'm going to have in this parabola. And by the way, that should make sense. You know why? Because I'm going up through that point right there. So I'm bouncing up. This is my minimum point. I'm going up that way. Now, here's what you know. You can actually go down here and calculate and evaluate -6 as well, but you know what's interesting? And you probably should, honestly, just to verify. But here's a little shortcut. Since you know that this is my axis of symmetry, it's my mirror image, it's my mirror line. So if I'm going to go 2 to the right there, I can mirror it over here and put 2 on, or 2 to the left on that side and put another dot. It's a mirror image. It's the axis of symmetry. And if you do calculate -6, you'd see you actually do get 3. Okay, we got one more point to find. Let's take this -3 now. I'll do it over here to the left. So let's take the -3 and see what my y value is. So I take the -3, plug it in here for x, and calculate. I'll speed it up so you can just watch it go real fast. Here we go. Boom! There you go again. So -3 is what I got when I put in -3. Weird. So -3, -3. So that means at -3, -3, there's a dot. And I'll use my mirror image to get the other one here on the other side of it. So I'll go right over there. So there they are. Beautiful. So there is my table of values all done. We got nice little symmetry here, which it should be. -3, 3, and -3, 3. This is my vertex. Beautiful. So now all I got to do is just graph this thing. So here we go. So I'm going to do this as best I can. I'm going to do this. I'm going to start here and go up. And you keep on going. You don't stop. You keep on going. Put arrows on the end because it is a continuous function. So I'm going to keep on going here. Got a little wiggly there. Sorry. Like that. Bam. So there's your graph. Beautiful. Good job. So there's your vertex form. There's how you do it. Nice little recap. Here you go. You're going to, first of all, instantly determine what the vertex is. Got that? Plot it. And then you could actually, you know what? You could put that vertex in here right away because we got to generate and populate this XY table anyways. So instantly, take that vertex, put it in here. Step 2, know whether it's going to be a frowny face or a smiley face. Step 3, draw your axis of symmetry. That'll tell you what this number is, although you already know it because of the vertex. And then you populate your X column, 2 up, 2 down, and then substitute in, evaluate. You can then use the axis of symmetry to mirror image, and then graph your line, or graph your parabola. Beautiful. Pumped up. There you go. There's vertex form. Enjoy, and here we go.